supply chain attacks. So I kind of want to give a brief background as to what supply chain attacks are and get you up to speed on what they are. And more than anything, kind of get you to wrap your mind around what the importance of security in the software development lifecycle, the DevOps, process, the pipeline, so to speak. And we have some interesting takes on this, right? In today's society, DevOps engineers are everybody, right? And most product organizations, if you're a developer, you're provisioning your own resources. Okay, you're right sizing the workload. Things that used to be ops, right? Developers now get to do, and that's through the cloud. It's allowing people to be able to wear more than one hat, be efficient and be effective, repeatable, consistent. But with this comes inherent risk, comes new levels of trust, things that we hadn't seen before. So I want to get into one of my favorite topics, which are supply chain attacks, but specifically what they look like in the software space. So what is it? What are supply chain attacks? Well, I kind of broke down a little bit as to what I mean when I say supply chain attacks, but in reality, this is what it really looks like in today's society. This is what it feels like. This is the information that we can go back and look at to be able to better understand supply chain attacks. We got a few kind that I'm going to talk about today. Some of the more interesting kind because of the levels of execution that they take to pull off. Right, advanced threat actors typically are able to pull off supply chain attacks. So, digging into one of the first ones that I like to speak about is compiler attacks. I know you're probably thinking, okay, like what do you mean compiler attacks? Well, there are Visual Studio, back when Visual Studio cost a lot more than what it costs now, or maybe before we had, that cushy desk job where we had instant licenses, thanks to being, had an E3 license, right? We used to go out and grab softwares from all types of places, all over the internet, right? Quote unquote pirated softwares. And a lot of people, this is how we get access to our first bit of professional tooling, our first time ever actually going to look at what professionals do and how they interact with their tools, what their tools end up actually looking like. One of those tools, I mean, of course, you got Photoshop and Illustrator and all of those things. Everybody remembers CS4 and CS5. Those were the days before we went into, Adobe Cloud. Everybody had a copy of this growing up, right? For kids like me, I used to want the latest and greatest Visual Studio, which was money, because it did intelligent things like help you write better code, help you debug your code, right? They had all of these different advanced software capabilities that I had to use. I had to learn. But I didn't have the money to pay for them. So what happens? Well, we go out on the website, we go into the Google, we look for the piece of software, we find it, we download it 70 times, torrent over here, torrent over there. Eventually, we run into the situation where we have to quote unquote crack the software. Well, through that process of cracking the software, we're exposing ourselves, we're trusting that this crack is not going to do anything, negligent or negative to our environment. So non-genuine software poses a specific risk to any environment. But in this example, I want to talk about compilers. And compilers are things, again, like people like me, programmers, we love to use. People like us, developers, we love to use. And if somebody has backdoored or given you a poisonous version of your favorite compiler, most of the time that compiler is running as root or system at a higher privilege, right? So we're able to potentially, as threat actors, get a payload, which is malicious code, malicious software, Trojans, remote administration tools, backdoors. We're able to get that into developers' environments where we can then read their code, grab their secrets, their certificates, etc. And so if you have somebody who maybe is starting a software company, is a very young software company, can't afford the tools, goes out, downloads these pirated tools, they're opening up themselves to risk. And not only do they have their software and their secrets that they have to worry about being taken from them, they have to think about the thing that they're actually creating. If they're making a piece of software that people are ingesting, there's the potential, the inherent potential for attackers to be able to take malicious code and inject it directly into the binaries that come out of the compiler. Okay. So that's the first type of supply chain attack that I want to talk to you today. Pirated software, right? Very dangerous. The second type, ATM malware, right? Everybody imagines being able to walk up to the ATM and go, dude, wait, doesn't everybody, or is it just me? Walk up to the ATM, beep, 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 brrr, all the money just comes out. Who doesn't want to be able to quote unquote jackpot an ATM? I mean, that seems like movie level stuff, right? Watch Dogs. You hack the ATM through your phone and it just spits out money. It's like movie level things, but except it's happening over in countries like Russia, over in countries like Ukraine. They're dealing with these malwares known as green dispenser. And green dispenser is a piece of malware that gets loaded onto a ATM by a person that has physical access to the internals of the ATM. So again, a trust boundary is breached. There is a provider of services to ATMs, the ATM technician that has keys to the ATM, that has advanced understanding of the ATM, right? And is able to manipulate and or load software onto that ATM for malicious purposes, allowing for quote unquote jackpotting, which is when ATMs dump their entire cassettes full of money out, right? And this is how cyber criminals are jackpotting ATMs, right? And the key there is that there's some provider of services somewhere or someone that understands deep domain expertise on ATMs, how to actually access them and what payloads to put on them to be able to retrieve the money. This could be a technician that you're hiring that just is rogue, right? Insider threat. Insider threat is when, an employee who otherwise is not rogue has gone rogue, right? Our third supply chain attack is something that happened back in 2017. And this was the first time we had seen something to this level, which was a piece of software, a package called MEDoc. And MEDoc was used by a number of Ukrainian financial providers, people who are doing taxes and banking, etc. And the core code, the actual code that comprised MEDoc, that actually made up MEDoc, was infected. It was then used to be able to spread a virus that was dubbed NotPetya. And everyone who subscribed to the MEDoc financial package was infected with that NotPetya virus. NotPetya was a very nasty virus, and it spread very, very quickly over the internet. And it was the first time we had seen something of that caliber happening in public space. Another example of a supply chain attack is the latest and greatest SolarWinds. Just in December of 2020, we were made aware, just a few months ago, we were made aware that software giant SolarWinds, who is a Texas-based company, has been around since the late 90s, I believe 1997, Um, Google that, I believe about 1997. Survived the dot-com bubble, survived the 2008 crash, right? The last recession we had, but could not survive attackers being inside of their code base. And the way that attackers made it into their code base was very, I feel like, plausible for all of us. There's a mail relay run by Exchange. This Exchange server had a vulnerability that was not patched. The Exchange server was compromised. At that point, the attackers took the time to actually do enumeration and understand the environment and found someone with highly privileged credentials, admin credentials, an administrator. This happened to be a developer. Using these rights, they were able to go in and actually write bad code into the SolarWinds Orion platform. So what they did was they replaced a DLL, a dynamically linked file or dynamically linked library, which is just a file that Microsoft uses to be able to load up some type of functionality as it's running a program. It replaced a non-poisonous DLL with a infectious and poisonous DLL. And what that did was allow the attackers to have something that's called command and control. Right? And command and control for attackers allows for attackers to send commands to victim machines and actually have control over them. Tell them to go and do things like install more malware, go out and use for different attacks. In this instance, since the command and control software was being loaded based on the subscribers of SolarWinds, these attackers immediately, from compromising one user and compromising one vulnerability, was able to compromise a large numbers of organizations that otherwise believed they were secure. Could you imagine using your Windows computer, not knowing that somebody is behind your screen looking at every single thing that you do? Imagine if you deal in AI. Imagine if you deal in finance. Imagine if you deal in military or defense, which, by the way, SolarWinds has companies that deal in their product, that purchase their product in finance, in military, space, and defense, right? Some of the country's largest IT companies consume SolarWinds as a platform. Even Microsoft, the creators of Windows, consumed SolarWinds. And due to the breach at SolarWinds, it was found that attackers had actually tried and attempted to edit the source code of the latest Microsoft Windows. Along with this, it is to be assumed that the Microsoft source code was leaked, all within the last quarter of our lives, right? Supply chain attacks are hitting hard, they're hitting fast, and not playing fair. These attackers, they're moving very, very quickly. Outside of that, why should you care? Why would you care? Well, I already told you, developers are now DevOps engineers. They're shifting left. Security is shifting left, right? So this is allowing for everybody to be able to produce these documents, I like to call them, these scripts that allow for the orchestration of environments, right? This allows for me to be able to spin up a server, provision a firewall. This is the cloud, right? When we're moving into this cloud space, we're all cloud engineers now. We're all DevOps engineers. We're all software engineers. And now we have this unique responsibility to keep our secrets safe, keep our customer data safe, right? These are the things that make our companies as developers. So now that's falling on us. That used to fall on ops, right? We used to have an ops team where we could call up and say, hey, I need to use PHP 5.4.6. I need to have 2 gigs of RAM for this web server. I need to have Apache 2.4.5. I need to have, MySQL stood up, the latest version of MySQL. I need to have 3 users. I need to have the configuration to be set up so that the virtual host points to this domain name. And I needed to have TLS. You used to be able to put this into a ticket, and 2 or 3 weeks later, it would just fall out of the sky. Here's all your information. Here's the access. Here's everything you asked for, right? There was somebody who was highly skilled and dedicated to just operations. Linux systems administrators, Windows systems administrators. Those people are eroding. Their responsibilities are eroding away from them right before us and being passed down to us as developers. It is now our responsibility to right size our environment, making sure that we're not using, instances that are too small, right? Instance being a host, a virtual host in the cloud, making sure that we're not making them too small or too large, right? We don't want to spend too much money. We don't want to crash the system, right? Making sure that the S3 buckets that we use in Amazon aren't public, right? So that everybody can't go and get our data. Making sure that we're backing up our environment and that we're following 3-2-1, right? The 3-2-1 principles for backups. If you don't know that, go look it up. It's really good to practice, even for yourself, right? So these are some of the things that lead me to the first point of why you should care. Developers now have more power than ever for security, operational excellence, okay? And you have to ask yourself every day as a developer, you have to act like an architect now. And you have to say, what tech am I using? Where are my repositories? What are in my repositories? What packages must I use? What versions are they? And if they're out of date, how do I update these? Right? This is one paradigm of the continuous security mantra methodology that we follow over at Enterprise Offensive Security, helping people achieve security operational excellence, SecOps, right? Who's managing verification processes? That's one big lacking gap in our environments. Who manages the verification? Who actually says, hey, this is good to go? Who's the architect, right? What update procedures are in place if that architect gets sick, goes on vacation, right? A lot of customers aren't thinking about this at this very point. And we have to shift left and start to accept as engineers, as developers, that it is now our responsibility. It is now falling on us. We are now the front line of security. And what is the impact of that, right? I'm gonna get to my demo soon. I know y'all want to see the demo. We're gonna get into the demo. I just wanted to get y'all minds turning about this because it's so important. And the people that are sitting in these chairs right now have the most power. You should be the most empowered group because you use this stuff. You use Python, Ruby, JavaScript, .NET, PHP, Node.js. You are using the third-party repositories like PyPy, Docker Hub, Pair, right? The apt repositories, right? Aptitude. So these are some of the things that we're interacting with on the day-to-day that actually have high levels of impact on security. Running the latest version of Python, are you still on 2.7? Because I'll tell you what, it's no longer supported. So you shouldn't be, right? Are you running the latest version of Ruby or Ruby on Rails? Which version of JavaScript are you running? Does it have any vulnerabilities? Have you addressed them, right? Not only that, but knowing what exists in your environment so that you can better harden your environment is step one. Understanding what's in the environment, right? Packaging. How often are new packages added? How do you trust it? How often are packages updated? How far behind do they lag? In the Mac world, You got brew, got something else. I can't think of the other one. But they're different. Mac ports. You got brew and you got Mac ports. And these are package managers, right? And the reason why I bring them up is depending on the version of software you need, depends on what version manager you should go with. Because it is known that Mac ports stays behind while brew is bleeding edge. Sometimes staying behind is good for you operationally, as long as there's no security or operational risk. While being on bleeding edge is going to provide you less stability maybe from your software, but the latest and greatest features and security concerns, correct? So impact is going to vary from environment to environment, all right? And last but not least, trusting of tools. How do you know that you can trust your tools? How do you know? Because you go and read every line of code. That's a good step. You should read every line of code. You should understand exactly what's happening in your environment. Because you put it through security review and you have an actual security committee, that's a really, really, really good practice to have, right? But even with all of that, how do you know you can trust it? And I think that that's where security lives, and that's where our opportunity is as developers. We have to remove trust from all of our decisions. We have to actually not have a favorite. We have to be more objective about this stuff. Okay. I'm going to try and share my screen. Give me 1 second here. Hopefully you like what I got for you. They don't do a good job of letting you know which is which. Okay, no, that's not that one. That one. Hopefully that switches over soon. There we go. Okay. All right. So if you have gone over to the Detroit Black Tech Hacking with the Homies, whoops, it's always fun. Going live is always fun. If you've gone over here to the Detroit Black Tech Hacking with the Homies Developer Conference 2021, you will see on day 2 at the very bottom, zero trust in the cloud. Like how that came full circle. I feel like a comedian. All right. So you can view my slides, but what I want you to do is check out my repository. And this is one of my good demos. I like this one. When I got it working, I felt really proud of myself, because what I'm going to do is I'm going to show you how to do your very own supply chain attack. And I'm not going to get too malicious because this is my environment and I don't want to hurt myself, right? But I do want you to get a better understanding of exactly what attacking the SDLC looks like, and injecting code into pipelines and that type of stuff, right? So there's in this repository we have 3 folders and a README. All right. So we have an evil deployment. Don't worry too much about this. This is if I want to put it out into the world. You can have fun with it if you want to. Feel free to go ahead and play with it. I got an evil Docker file. This is going to be the Docker file that I'm going to target Jessica with, because I know that she wants to stand up some piece of software like Sonar or something really, really quick and easy. So I'm going to go ahead and put out my evil Docker file into the world. Sorry, Jessica, I had to pick some name out of there. Maybe it's Eddie. Maybe you guys are working together. And then what I got here is the Malicious Nginx, right? And this Nginx is a web server. It's very much like Apache, very fast, good at routing. And I picked it because it was very easy for me to demonstrate the way that I can set up a routing rule. I'll dig into it. So what is all of this about, right? We all know about like how to do like curl, and then you like pipe, and then you like go and pass the actual output of whatever it is that you curled into bash. And it's really, really icky. But in I'm personally one of the people that think it's kind of bad. But in Docker world, they have something called add, ADD, add. And this allows you to be able to kind of do that curl pipe sudo bash thing, right? Where you curl and you pipe and you sudo and then all that information into bash, right? So I learned this from some folks over at Black Hat. I watch a lot of conferences, not only the American conferences, the European conferences as well. Very smart people all around the world. One of the things that brought you here today is because you are seeking information. I'd suggest that if you want to learn more about this topic, please go over to check out the Black Hat EU 2019 talk that I linked, where they reverse engineered, and built exploits out in the cloud. It's really interesting. So I'm going to jump directly into this thing because I'm an attacker and I know what I want to do, right? So here, let me see if I can make this bigger. What is it? Which one of these buttons? There we go, that way. Yes, sir. All right. So now that I have your attention, yes, I use a very interesting shell. It's called ZSH. I say go give it a try if you like. So what we're going to do here, and if you're following along with me, we're going to clone our repository, which we've done, right? We have our evil deployment, evil Docker file, malicious Nginx, and our README. All right, so we're going to CD into that directory, which we've done. And then we're going to go ahead as an attacker and stand up our malicious Nginx document, Nginx server, excuse me. And since this is all Dockerized, you don't have to do too much thinking, but I will actually open up these Docker files for you. Oh, I could do it right here, actually. That'd be much quicker. Here we go. So inside of my malicious Nginx folder, I have a config file, deployment, some static files, and a Docker file. All right. So inside of my Docker file, what I do is I copy the exploit config over into the confd default. That's for my Nginx. I take my static files and put them over into my HTML directory, and then deployment goes into my deployment directory. And what happens is it's over here inside of my exploit.conf, you see right here, as an attacker, I'm standing up a server on port 80, all right, default server. And what I'm doing is I'm setting the root to be this this directory, with that being the index, all right? But this is what happens when any old person comes along. Now, I've used this keyword map right here. And what map does is it allows me to be able to select things like the user agent, to be able to actually check to see if the user agent is the default or if it is this special go-http-client dot user agent. And then that will actually run what is called exploit.sh. Now, let me slow down. You're probably thinking, well, what just happened? Okay, work with me here. Me and you, we go visit this thing, it's going to look normal. But if I go with that header, that user agent that says go HTTP client, I'm going to get a different file. So let me demonstrate that. The quickest way for me to do that, continue to follow the instructions. Go over here and build that Docker. All right. And I'm going to copy and paste her. Oh, whoops. Good thing I didn't hit enter. So I go ahead and copy and paste that into there. And now it's doing this thing. It's going and it's resolving Docker IO and it's extracting and it's building stuff. Cool. All right. Now it's built some stuff. Now, one would assume that there is something stood up on localhost port 1337, because that is what that command that I just ran does. Oh, no, actually, not yet. We want to go ahead and copy this Docker run, put it over into here, and then we run it. Now, what that just did was take port 80 ported over to port 1337, which means we're elite, and then runs the Nginx. And if you go here, at this point, if you're following along, go to localhost colon 1337, and that is what pops up, Nginx. All right. Now, the very next thing we want to do is do what we would as a victim, right? As a victim, we're going to come along. We're going to have this really cool Docker file that makes our job so much easier. So easy. It's just like, oh my God, I found this awesome Docker file. It's got everything I want in it, right? Let me go ahead and read this Docker file because that's the first thing I want to do, right? So I'm going to use cat to be able to read that. CAT. Cat this Docker file out. So I'm reading this Docker file. Okay, copying basic files. It copies the .sh into the root directory. All right. For security reasons, we check for newer versions of the installer during Docker build time. Definitely not changing the wrapper or installing backdoors. This could be machendrix.org, right? Doesn't matter where. We stood up the server as an attacker, right? So this is the attacker server, and it's asking me to go over here and visit this and run the add command. Now we already know what the add commands does. It does that sudo bash thing where it takes some information from the world and actually runs it, right? And so as you see, when I went to localhost 1337/script/installer, as that add says that we should be doing right here, that add is actually going to go there, get it downloaded and run it. So we're going to go get it, open it up with text editor or something, right? And when that pops up, what do we see? Oh, I don't know that I can make that any bigger, unfortunately. There it is. What do that say? Installing everything needed by our application. Well, I don't know. I mean, that could be an @get. That's an @update. That's anything. I mean, I'll be honest with you. As a security engineer, as a person who's a hacker, that looks perfectly standard to me. Like, I would not be afraid that it was installing stuff that was needed. Like, it literally right now, I'm looking at it. It does nothing malicious. Nothing at all malicious, right? So, as an attacker, if we go back over to our malicious Nginx, we have our static files. We have an installer sh and the exploit sh. Okay. So we just saw the install sh, but how did we get there? Well, remember our static files got copied over here to /script. That's what we just visited. Okay. Now we have this config with this exploit conf, but we just got regular old installer.sh. Right over here in this map, we went with a normal old user agent that wasn't this user agent. And so we got installer.sh. So if I'm a forensics person, if I'm your boss, your higher up, part of your security council, this is all on the up to me. I mean, it looks pretty standard. There's no problems for me. No bells are ringing. I mean, at all, right? So as the victim, I've run it up the chain. Everybody seems to say that it's fine. It's just gonna, execute that installer.sh. Seems pretty fair, right? So I get permission to go ahead and run it. Now, this is us operating in the way that we would expect to operate in the environment, right? And so I go ahead and I paste in the command and it's building. And oh, what is this? Definitely not running exploit code. Adding files to your, wait, where'd it go? What was that? What? I have now just deployed ransomware onto your entire environment, machine by machine. I'm encrypting all of your volumes, all of your Docker containers, everything. And let's be honest, you don't sit here and read all of that. You today, you folks at home, you don't sit here and read that. That is not what you do. You don't sit here and read every single line of a Docker container being built because there's sometimes 10,000 lines in a Docker file getting built, right? It looks pretty standard. It doesn't have anything that says that this actually went out and did anything malicious, but we know for a fact that it just did, right? So right here, as you can see, I kind of grabbed this output, definitely not running exploit code here, adding files to your container and changing the wrapper script, sorry. Now, where does it ever say that? Well, if you look over here into malicious, whoops, and we go into static files, and we go into the exploit.sh, definitely not running exploit code here. Adds the file to our container, changes the wrapper script to actually run that exploit code, right? Spends 300 seconds just so I can actually make it pop up so you can see it, sleeps and then goes to done, right? So what I'm demonstrating here is that even if you are practicing the utmost security and you have the best understanding as to what's happening in your environment, and you have people that are actually looking at your environment, combing through it to make sure that it doesn't have any malicious code, you still won't be able to outsmart a person who's assuming that you're doing all those things, who's intently trying to outsmart you. This is cat and mouse. This is where us as attackers live. And let's be honest, I don't think the goal is for you to be able to figure out a way to, find the next biggest emerging threat, right? I don't think that's the goal of this talk. What I want to do is make you aware that you can't trust everything you see. That if you see something calling out to a remote server for it to be able to grab dependencies and put it into your environment, that should raise suspicion immediately, right? These are the things that if needed, go out and grab that actual file from that person, that installer.sh, right? Save it locally, stand up a local web server, change that inside of the Docker file to actually be served via you. Or don't do the add at all and just do the sudo bash dance, right? But how many people in the world have Docker files that may have something like this running in it? That's just one quick, easy way to be able to demonstrate to you how easy it is for me to be able to be in your pipeline, running and executing code with even you intently looking for me to do it. Trust nothing, right? There is no level of trust that you can have. You have to be extremely cautious at every turn, not use, software that's pirated, not use packages that are old, have a package management routine or regimen that actually goes through and addresses aging packages, right? Scan for aging packages, so the security and compliance risk, right? Even my talk last year, I discussed what it looks like to actually scan your code as it's going into the pipeline. I've now helped 3 customers do that exact thing this year. That still wouldn't necessarily make, that wouldn't necessarily catch these types of bugs because it's going to go with a different user agent than what we know the user agent of Docker to be, which is the Go HTTP client. And that was the thing that we actually keyed in on to be able to make sure that when forensics people and when analysts are actually going out to go and look at every single URL, that they don't get the same payload that this piece of software that we know we're targeting is going to use. This is a different user agent, a very unique and specific user agent. So with that being said, I'm trying to share my screen one more time. I know it's madness. But with that being said, let me share my screen. Sorry. Right. How now going back to this, how does it impact us? Right. Inventorying your technologies, understanding what's in your environment, understanding your repositories, what it's actually going out to get. One of the things that it did was it went out and grabbed Docker from a Docker place, right? From where all of the different Docker files are living. I believe it's called Docker Hub, right? That's something that's standard in Docker. You don't have too much control over it. That's a repository. And inside of that, what did I do? I added another quote unquote package, right, from my own repository on my website into your environment. So I injected a package into your environment, right? How do you know what packages are there? How do you know when, like, do you whitelist the different URLs for where package updates happen? How do you keep malicious code out of your environment, right? And how do you know that you can trust your tools? I don't think that you can ever trust your tools. Not at this time in security, not at this time as developers. It's too imperative. Thank you. I appreciate you taking the time to listen. Hopefully you saw some stuff that made your brain itch a little bit. Hopefully it scared you a touch. But at the same time, I wanted to empower you so that you can understand what you're up against, so that you can understand where the security space is headed, and kind of stay abreast.